Welcome back to Made of Wires. We're decompiling Castlevania Symphony of the Night. If you're not familiar with the Castlevania Symphony of the Night decompilation project, go to soten.z.dev and you can see the progress that we've made so far. We've been working on the Sword Familiar, and we're going to keep doing that today. We started a function last week that we made some progress on, but not too much. There's still some stuff to figure out, so we're going to keep working on that today. I did look at, I think there's 4-ish functions left. We can go over and check. Related to the Sword Familiar. Let me get my editor set up. I was working on permuting one of the ones that was in progress earlier and haven't gotten a match yet. There's some funny addressing going on that I'm not sure. It doesn't look like things that I've seen before. But we won't worry about that today. We'll keep going here. So I think what I'm going to do to start off is clean up some of the variables that need cleaning up. I haven't touched this since last Thursday. When we left last week, what I had done was opened up DuckStation and set some breakpoints to try to find this function, but they weren't being hit. So we're going to have to find some other way or look into some of the related code and see where this might be. I'm just going to go top to bottom and where possible delete these, otherwise comment them or otherwise. This global actually is something that I probably have already decompiled. So let's actually take a look at that and see what that might be. I spent a long time looking at data, and I think I have all the data decompiled now. There's SBSS, which is not decompiled yet. So this is an array of sound effect IDs. And so we'll treat this as an array, and that's good just to know that we're addressing it correctly. Good morning, Orcam. Welcome to Cooking with Kaya. Good evening, Dig Down Deep. Good to have you back. So it looks like these, we have several of these that are XYZ. I'm going to put these in order and see if that affects anything here. Not quite the way that I wanted. So it looks like this B8 BCCO, it looks like that is being loaded as a vector, which means the X value is being set here. So we can get rid of basically all of these. The C4 is a little C4 being accessed means that it's not a vector, though. It is just a triple of words, which is a little bit different than how vector is defined. What I'm seeing with this B8, BC, C0 is that when these are being loaded, there are offsets being read for 0, 8, and so I'm gonna define a struct of the XYZ triple and see if that works. I'm gonna make a note of it here, and then come back because I wanna clean up stuff first. Pardon the ad, I will just be cleaning up variables. If you're not seeing an ad, thank you very much for subscribing. Hope everybody had a good weekend. Oh, congratulations, Entropy Gravity Well. Yeah, I think 10 years and 2 kids. You're probably ready to settle down. Now you could plan the wedding for like 5 years from now. Joking, of course. Yeah, seriously. Where are the... there's got to be some computer science problem related to optimal seating for in-laws and distant relatives and how not to put the wrong people together. Some kind of knapsack problem or something like that. There's some unproved theorem of some mathematician from the 1800s that selects the optimal seating arrangement. Oh, very fun, very fun. So I'm assuming you've been down there several times then. never been anywhere in the Caribbean. Been all over, but never the Caribbean. All right, so that looks pretty good. There is also the PSP version that we can look at. There are more variables that probably can go away. So let me see what other options there are. So in this case, this temp S0 is being set. And then I think is being used as one of these, kind of backing up to last week. When this was decompiled by M2C, there's a bunch of these subroutine args that are misinterpreted by M2C. And so we don't get proper symbols for those. And so actually working those out through M2 or through the PSP might be a better option. Let me go back though and look at this where I started. So my thought here was that this is probably a vector-like structure, except it just has XYZ. I'm going to try making that and see if I get the same offsets. So it appears that an address is being loaded and then offsets into that address are being calculated, which is why I think that. But then the way that this is packed in memory, every 4 bytes we have another referenced value. So if this was a vector, it would be a set of 4 32-bit values. And this really looks like 3 32-bit values. So I'm going to give that a shot and see if that does anything. So then each of these is actually one of those fields, and I will have to update the name of all those. So what I want to see on the target is oh, I need to fix the rest of these. On the target over here, around line 55, one more, line 100. Okay. Yeah, actually, this is looking like what I wanted to see. So we don't have the immediate value, and instead we have an immediate value plus something else. And in this case, it's taken B8. B8 plus 4 is going to be BC, which is what we see over here. B8. So even though these are in the XYZ order, they're actually being loaded and stored in YXZ order. Why does that happen? I have no idea. But that does look correct. And then down here on line 64, I was hoping for something similar. And I'm not seeing it. What I'm going to try is doing the same thing with C4. Well, that's good, because your entropy gravity well says he loves Jamaica. I'm guessing that is good, because you're probably going to be going back quite a bit. Closest to that area is that I've been is Cozumel, Mexico. Which obviously is not very close. Actually, I spent a lot of time in South Florida, and South Florida is close. Just never got across the water. Yeah. We're all invited to the wedding, right? See you there. Do you need a toaster? You guys probably have everything you need already. All right. Is there anything else that I'm missing here? Yeah, the bingo stuff is cool. I don't know if they have any integration, or if it's if Mozilla was on chat, he would be able to tell us. The ones that I've watched, I haven't watched them in maybe a month or so. It didn't seem like they had any integration with the emulator, so there's no like trigger based on the things in the bingo. That'd be super cool if there was, because then it'd be harder to cheat, but also you wouldn't have to necessarily keep track of your bingo, and maybe you get slots accidentally along the way. But yeah, I think that's a pretty cool format for tournaments. All right, so looking elsewhere, like around the same idea. Oh, so again, kind of this. This is one of the things that may break this rule, and a problem I was having with one of the related functions. So here, this value is being loaded again. And I'm not sure why. So at this point, I'm going to take it over to the PSP and see. Oh, I screwed something up. It looks like I forgot a parentheses. Maybe? There we go. So about the same on PSP. So looking down from the top, ours versus the original. V0 is the return value. Oh, this is kind of interesting. V0 is the return value of this particular function. And when these are being loaded, they're actually coming from V0 instead. So this CB8 function, which I don't think has been decompiled yet, appears to be returning a entity. And self might not be the right. So this is being stored in V0, and then V0 is being used for a bunch of other stuff. But then it's not taking. Oh, maybe I'm misreading this. Yeah, I think I'm misreading this. The value is being read into V0 as the temporary register. Okay, never mind. So I'm going to ignore most of the immediate and register differences at the moment. So 74 is the first place that I see anything of note. And the order of this shift is wrong. I don't know if that is actually wrong or if it's a change between the two. So shift by 7 is times 256, but then yeah, I guess that might make sense because 256 is about the horizontal resolution. The M2C likes to put these additional casts in that seem not necessary. Okay, so here's a sign extension. This is suggesting that start should be a 32-bit value. So let's see what that is. It's a sign 16. So possibly that this 07C is not the type that we expected it to be. Let me go over to see where else this is being used. So here's a very similar use case. I'm not sure why this would be necessary because the type is already a 16-bit value. And maybe that was just missed when I was integrating it. I'm going to get rid of this so that I can get a clean build. And for this again. So start should be a 16-bit value. I'm going to try replacing this here as well. Okay, that works. So it looks like these probably were cases where I didn't know yet what this type was. Oh, and something failed along the way. Okay, let's see which one of these didn't work. Much harder to do it this way than in decomp.me. Okay, so here, load high is going to treat it as a 16-bit signed value. Oh, and that's kind of what's happening here as well. Now that I think about it, this is being treated as signed 16 instead of unsigned, and so it's possible that this just is the wrong type, and that needs to be fixed. So here, instead of going directly to that field, wrapping it in a basically a signed cast seems to work. Well, this is certainly slow going. All right, so here there's references, it looks like, to self. And it may be this here. This may be just very out of order. Not quite. Oh, there we go. Just it hadn't compiled. So here there's a store to, can't rely on these immediate values, which makes this a little harder. This may be instead of using the offset to this address, we're assigning directly to it, which is kind of the same addressing issue that is showing up on the PlayStation side as well, where I expect it to be an offset into some value, but it ends up being something else. Oh, actually, that's these additional variable assignments. Those don't appear to be being used. So it's possible that this is a relatively simple fix. Let me try this. I'm not sure why this assignment down here would exist, but let's see if this works. So yeah, that looks better. However, there's a lot of immediate values that we can't tell if they're correct or not yet. There is still something wrong up here. It's possible that these are backwards. Or no, this should be a plus equal. Sorry, that's what's missing. Let's try that one more time. Yep, there we go. Okay, that's what was missing. The assignment was not there. I'm not sure yet if these should be before or after. I think this ends up being the same regardless, but yeah, I'm not quite sure. All right, down on 123. This assignment looks out of order, and so it's likely up here with this other one. These look, again, these are contiguous in memory. E7-4. Oh no, the 7-8 isn't. Sorry. Slightly better. There is this sign extend of the 0. That's a little strange. So this is taking the 0 register, which is it's register number 0. The value is always 0. So why you would sign extend it into a register instead of using one of the other forms of loading it, I'm not sure, but it does look like it's just placing a 0 into V1. I'm not sure why. V1 then is being written. What may be happening is that this is going into a local variable and then being assigned. However, let me try one more thing. It is possible that there's like an inline assignment like this. Yeah, so that gives the sign extend, but those are the wrong values. So this looks slightly better, but now there is a mask that's being done. So let me write this one more way. No, yeah, that's not. there's something there. Why target X is a 16-bit value, and it looks like this 078 global is a... Oh, it's unsigned. I wonder what happens if we change it to signed. That will break a lot. It doesn't, and in this case, it gets rid of that mask, which may help. I'm going to go look at that 078 and see if that's going to affect anything else. So 078 is interesting because it appears to want to be read probably as a field of something. My stub to get it to behave that way was to make it a array. And these computers are right next to each other. But I still get latency. So this works fine as a signed 16. So it didn't have to be unsigned. That's good. So that is a fine change. So far, nothing terribly complicated. We haven't gotten down here yet, though. That's where things are probably going to go off the rails a little bit. So I was doing a increment in line here, but the way the PSP code is written looks like this, and that looks correct. So we have to do the increment first. The major difference is, can MetroWorks keep that temporary variable in like an ephemeral register, or does it have to try to load it again? And it looks like it does have to load it again. All right, so then this pattern was elsewhere too, so it looks like it's doing a plus equals on this 64, and then doing a separate mask of this value. Yeah, and why this is done in 2 steps as opposed to all at once, I don't know, but that's the way it appears. We have another case where I can run this through the load half macro, and then that works fine. Basically, it's just changing the start to a signed value. Sooner than later, it's probably something that I need to go fix because all those are probably wrong. Same thing here. As above, 2 steps. And the same. Oh, I did load word instead of load half. Give me 1 second. Sorry, just doing stream management stuff. All right, so let's. Sorry, add in 3. I'll keep working on this and then be back. All right, so let's see what else there is. I'm going to take this back over and this is the PSP version right now. I'm flipping back and forth policy changes between the two. Nice to have you in the chat, if you can hear me. If you're seeing an ad, apologize. And I'll come back to you in a bit. Oh, good. So yeah, I'm flipping back and forth between the PSP version and the PlayStation version. The PSP version provides more verbose but yeah, we want to target the PlayStation version first. See you soon. All right, so yeah, I will repeat this as well. Thank you, Orcam. Thank you for everybody for putting up with all that stuff. So it's been actually pretty tedious going through the PSP version, and the PSP version is rapidly kind of getting to a match, but it didn't really affect the PlayStation version at all, which is that's kind of a bummer, but also the way it goes sometimes. All right, thanks Orcam for the heads up. Yeah, I added a little display, heads up display, but it is not very usable in the it tells me it does give me the time, which is helpful, but the timeline itself is stuck at 0 always. I don't know what it's a Twitch thing, so I don't know why it doesn't work, but it doesn't. All right, so what I'm looking at here is actually a little bizarre, and I'm not sure what to make of it. We're taking an index from the primitive buffer. Yeah, I mean, let's see, do I have this? I have my monitor over on the side to try to keep track of these things. Anyway, not working out. Need to figure it out. So back to Castlevania, though. So I have this. We have this primitive buffer. The way that primitives are. So primitives are the quads, 3D quads that the PlayStation is going to draw, and Soten basically has this array up front of a few thousand of these quads that are just pre-allocated, and functions can say, give me some quads, and basically, like you would with malloc, except this is with a fixed buffer, that function will return you some range of primitives that are all contiguous in memory. That might be an interesting function to look at just from like an algorithm's point of view, but it's pretty common to for an entity, which is basically anything that you want to track data for, to have an index into that primitive buffer, grab a pointer to one of those primitives, and then do something with it. And it's done exactly like this. We take a reference to the buffer, grab the index that we've been given, and then use that pointer. The way that this is written or compiled on the PSP, we're subtracting a value from this. Let me actually look at the decomp. Hopefully that works. It's just such an odd... okay, so we're here at case 7. And yeah, there's no sign of subtraction here. So I'm really not sure what would cause any of this to generate some subtraction, a subtraction instruction. It's multiplying by 8. Offset 64 for V1. V1 is self. So let's look at offset 64. Maybe there's something there that I'm missing. I'm guessing that's the primitive index, though. Yeah, that's the primitive index. So we're multiplying that by 8. This seems to just be the... Oh! I know what this is. Oh, it's a bummer. I always forget about this. So the PSP version has different size primitives from the PlayStation version. And I don't have that in my definition. And so, there we go, that's fine. The subtraction is, this is just an optimized way to calculate a multiply by 34. Okay. Entropy gravity well, you're upside down. Okay, so let's see. Yeah, there are cases definitely where they do use negative offsets into arrays or pointers that we've seen before. So a bunch of this stuff looks like it's out of order, and I'm guessing we'll see some of that down here. So RBG should probably be RGB. And then there is a there's some value that's on a stack pointer that we're missing. Oh, and yeah, I caught this last week when we were working on it as well. At some point, this next pointer for the next primitive is getting overwritten, but then being reassigned down here. So either this needs to be pulled out into a separate variable, or something else. I'm going to look down here quickly and see what order this should be. Usually this is up near the draw mode. How much of the SDK do we have to reverse engineer? Sorry, I didn't see the comment. Actually, a reasonable amount of it. And I was looking at that over the weekend. So I've done a little bit of the SDK decomp. There's portions of the SDK that get built in with the game, and they're shipped in the SLU binary, whatever the product code is. That's like the entry point binary for the game, and that has the main function which gets executed. And so in that binary, which is the lowest address of executable code, a lot of the SDK functions that are used, and it looks like there's pruning in there because not everything is in the SOTN binary. A lot of that then is built into that. And so we've had to do some decomp there, a lot with like the geometry transform engine and the sound library. And I've tried to go through some of the libc. A lot of the libc functions look like POSIX libc, but they're actually implemented in BIOS. And so depending on the version of the SDK that you have, those will be trampolines into BIOS. Hey, Nate the Great, good to have you back. So over the weekend, actually, so Sozu D is one of the longtime contributors to this project and has been working on it for much longer than I have. He's also started a project called SciQ. So the Sony SDK was called SciQ, SciQ Decomp. And I was looking to contribute some of the code that I've done for SOTN Decomp to that project, which isn't much, but it's something. And so I did the memmove implementation, which is very short, but the way that Sony engineers write code versus the way that Konami engineers write code, I guess they would have been called programmers at the time. They didn't distinguish themselves as engineers. Is very different. And in general, I think most of the Konami code is just very straightforward. No huge tricks. This Sword Familiar actually had more tricks in it than most of the code that I've seen. The Sony code, on the other hand, is super terse, and just for simple things, just really hard to decompile. So I was working on the binary compare and memcomp functions over the weekend. They're the same implementation, slightly different signatures, and I'll pull that up. Let me load it now. If you've seen a binary compare implementation, so binary compare takes 2 pointers and a size, and tells you if they're the same or not. 0 if they're the same, and it's in a poor state at the moment. But so the way that you'd normally write this function, or could write this function, you might say while n is greater or equal to 0, decrement n if it's greater or equal to 0, if S1, and we're going to increment, is equal to S2, increment that, or sorry, not equal. Then we're going to return the decrement of S1 minus the decrement of S2. This is like extremely terse version of what this function might look like. And you'd see this not dissimilar things in NetBSD or FreeBSD or Darwin. I haven't looked at the GNU implementation at the moment, but this obviously this is not how binary compare was written by Sony. And I've done a reasonable amount of spelunking through like I think I found sysv code from the time. Like, did Sony write these functions themselves, or did they license a Unix? And this came from one of the Unix vendors at the time, or how did this come to be? Because these are all standard libc functions, and I don't know. It looks very much like they wrote it themselves. The other one that I've been working on for months and haven't, it's much longer, and so it's a bit more complicated, is the sprintf function. Let me see if I can find that one. That's the same way, where it's already a difficult function logically. There's a lot of things that you need to keep track of. And looking at contemporary implementations, it just looks like this is uniquely Sony. And they specifically say in their documentation some of the features of sprintf, like string format wise, that are supported or not supported. But then looking at their code, this set of supported things is actually different from what the documentation says. For Symphony of the Night, it's GCC 2.6.3. And then there is a specific assembler for the PlayStation. For get rid of that. For the PSP, it's MetroWorks, and for overlays, stages, weapons, things like that, they didn't compile with optimization on. And so we get really nice linear code that is not nearly as verbose. So yeah, this next pointer here should have been something else. It should be another variable. Anyway, yeah, we get very different. Their documentation is actually really good, and it's a different era of documentation. So I'm going to need to grab another primitive. I think that maybe I could just rename these. Let's see. Where was that? So I think that... So this is going to get us to... Yeah, I do too. There's actually things that I'm often surprised don't appear in man pages. So let's go look at this. So the decompiler comes up with a very different loop here. What I'm trying to figure out is whether or not, so we have these let's see, Vars 5 is, this is our primitive, and S0 is next. When the decompiler, so M2C is the decompiler, it usually doesn't understand, well, not usually, it often doesn't understand sizes of things. So when it's doing plus equals 8 for pointer arithmetic, usually that's saying, in this case, we're looking at pointers. So it should just be moving over 2 pointer values. But this is not a pointer. And what is var v0? Var v0 is 8. I wonder if this is a mem copy. I'm gonna go, no, that's, these are not the right types. Or this is just completely wrong. Yuck. So we're grabbing this value, comparing it to this other value that's in BSS, which is uninitialized data. We can go through and see what sets that, or when it gets set. And then here's our so I think what's happening is this is supposed to be prim along the way. We do end up doing like a mem copy here. So let me do this. Next is going to be equal prim.next, and then I think the mem copy is done. We're still missing this store word. Yeah, okay, so this loop doesn't actually exist. It doesn't exist. I mean, this is implicitly done through the mem copy intrinsic when these two structs are assigned to one another. This is getting saved to register S2 instead of being saved back to a stack variable. And then the last part of this is what should next actually be. Okay, so this okay, so we're looking for one past where prim is. So at this point, next is sorry, wrong order. Next. Too many nexts. I think this is what we. I'm off by 1 here. Yeah, I'm off by 1. It's closer than what it was, but there's an extra load of this. The pointer after our current, and so either we need to save off the previous value, and so we have where prim is. I don't know. I'm gonna keep going and try to work through that in a bit. So here we have another increment and then the check here, so we can get rid of most of these temporary variables. The primitive assignment should work out pretty reasonably. So what's happening here? We have an extra store word, load word. I think this is the opposite of what was happening earlier, where this is being incremented inline. Oh, and it's going to make me a liar again. All right, so what is happening there? Oh, that was odd. Oh, it was just the variables that were causing it. All right, now we have this mess that the PlayStation version compiled a bunch of stuff that M2C couldn't figure out. So we're gonna have to figure that out for M2C. So we can first make some nicer variables. So we have X0 and Y0, X1, Y1 offsets. It's probably the best names for these. These may actually be happening in line and then being optimized out. We can look at the decomp here. And see what's happening if these are being pulled out. Yeah, okay, so these are. So I'm gonna rename these just X1, X0, X1 offset, Y0, Y1 offset. And we should be able to get rid of most of the cast there too. Oh no. There's a few others that are being calculated as well. Others that aren't. So I screwed up something along the way. The ad I saw off to the side was, I hope, not an ad about what Twitch thinks of me. All right, so we're calculating some new offsets, and these should and likely are very similar to these other calculations up here. We just need to get the ordering right. And why they get put into the subroutine arg registers, I'm not sure. Yeah, they won again. So let's go over to the so we have these subroutine arg 4, arg 8, etc. Those were M2C on the PlayStation side, not knowing what was going on. So we can come over here to the PSP side and get a better idea. So we need to look at where our assignments are happening, and we're primarily concerned with this 1A and 2-4 assignment. And these are pulling from SP4C. Sorry, the 1-8 and 1A. So SP4C is RA1. RA1 is not the argument to the sign function call. It is unknown C, which is the same as x0, so this is just x0. So why this was being treated specially, I don't know. And my guess is that then this one is x1, and likewise y0 and y1. And we'll check this after we get those back in place. Still not compiling. Missed some parentheses somewhere. All right, so let's go down and look at where those are. So not perfect. So we have a subtract when the original looks like an add. And let's see. There is a load of offset, stack variable 46. That could be because our variable is already in a register instead. That's coming into V0. So I'm not going to spend too much time on that. There is this one though online. Early on, it is loading this word the x0, x1, x0, y0, x1, y1. Those are probably supposed to be signed 16s, and not words. And let's see how that looks now. Still another variable on the stack that's missing. These stack offsets we can control later, or try to control. I'm not too worried about them at the moment. If the things are in registers now, that's also not something we can control directly, but can try to coerce it later. Other than that, all the instructions look the same with yep, all the instructions look the same. So stack differences, immediate differences, that's going to be the case between the two systems. So I'm I'm reasonably satisfied with that. These are matching, again, stack pointer versus likely something that's in a register. So there's the casts here that M2C puts in start adding masks that are unnecessary. Most of the time, this logic can be done just in the 32-bit space. And the cast just cause MetroWorks to confuse itself. And this looks like one of those things where it's all going to line up and be a fairly consistent set of calculations. So this is the same thing where subroutine arg4 was x0, arg6 was x1, and arg8 was y0 and y1. So a good question might be, oh, this is arg-A. Oh yeah, that's fine, y1. A good question might be, why are all these being done over and over? Here we have it. This should be an add. This should be a subtract. This is probably a subtract. So most of this, I guess they are slightly different. Yeah, so each one is the y0, y2, and x0, x2, x1, x3, y1, y3. Those look the same to me. So why are they being done twice? I don't know. I'm streaming off of Ethernet, however, I can make sure that's the case. Wi-Fi off just in case. My internet connection is relatively poor here, and I need to upgrade to fiber and get a symmetric uplink, but I haven't done that yet. Sorry if things are dropping or if the feed looks poor. Am I at 30 or 60? Yeah, I definitely don't need to be at 60 frames a second for what I do. Yeah, I am. I can do that tomorrow. Drop it down to 30. Most days is okay. Today I noticed other stuff going on in the house that was poor. Yeah, 120 frame per second decomp. Okay, so this has gotten up to 87. The last time I checked it against the PlayStation, it was at around 77. So let's see if any of this had any positive effect on the PlayStation side. Hopefully a little bit. A very little bit. From 70.68 to 70.95. Wah wah. So the definitely not ideal. What is interesting, I think, and this is a good reminder of what an optimizing compiler does versus a non-optimizing compiler. We'll go through, and on the PSP side, we'll go through, and the code that we have looks a lot like the assembly that it generates, and you can kind of walk through line by line and see, oh yeah, it makes sense. Let's see, where's line 216? All this math. Okay, multiplications are a little complicated, and we have overflows that we have to look at. That's okay. I can deal with that. There's an addition. We're going to shift right by 12. That's fine. We're going to load this value. No big deal. And then we're going to store the value. Okay, that makes sense. When we look at that same thing over on the PlayStation side, what gets attributed to this particular line is these 4 instructions. Obviously, more is going on than just these 4 instructions, but it has done the optimization. Like I mentioned earlier, these equations look the same, and so the optimizer is going to come through and say, yeah, those are the same. Or I can take out the temp2 times temp s2 times x0. You're doing that multiple times, so I'll just throw that in a register and reference that register. We don't have to recalculate it each time. And a lot of that's up here then. And so we have these instructions that may be attributed to a particular line, but really they're being shared amongst a whole bunch of other things. But there is more going on here, so it is possible that I did get something wrong along the way. And that would need to be fixed. Yeah, fortunately, most of the compiler settings, there may be a few cases where they differ for a particular overlay or maybe a file, but for the most part in this project they're always the same. The big difference or exception, I guess, to that is the main entry point binary on the PSP that was compiled with optimization on. All of the overlays are compiled without it on. All right, so it's been about an hour and a half. That's where I'm going to end it today. This one is going to take a little bit more time, but that's okay. We were able to go through and get rid of some of these. Some of the data types, I think, were cleaned up from other things in the Sword Familiar, which is helpful to have and will help with something else. I think I might shelve this for tomorrow and go back to one of the other 3, and I'll take a look at those and see. I'll try to find one that I can hit with a breakpoint, and then we can play through the game a little bit and see where that's being hit and try to figure out what it might be for. if you want to know more about the Castlevania Symphony of the Night decompilation project, you can go to soten.z.dev. I didn't post any of the links to the scratches in decomp.me. Decomp.me is the tool that we've been using. But if you saw them in the stream, you can go to any of those and make your own forks and see if you can get any further along the way, and come back tomorrow and educate me as well. On soten.z.dev, you'll find a link to the GitHub repo with everything that we've decompiled, and you'll find a link to the Discord server where we are chatting about this. I spent a little bit of time over the weekend cleaning up a good bit of the Sword Familiar code that hasn't been checked in yet. I think maybe there's at least 20% more of the code. So here is Sword Familiar. At least 20% more is completed, and I just haven't gotten around to submitting a PR for that yet. But I'll try to do that this week, so we can see some progress there. It's always nice to have progress. But that's all I have for you. So have a good day, and I'll be back tomorrow. Adios.